just warning you now, there's going to be no conclusion to this video. There's no way I'm fixing this today. It's not going to happen. Hi, it's Sony RX100 Mark IV repair time again, and I just did that like 57-minute previous video, so I thought I'd go back in there and take a look, but unfortunately, there's a fully charged battery. This is what happens today. Nothing. Wah, 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 wah. It does not power on anymore. It's back to its original fault condition. What the? I cannot cop a break at all on these type of repairs. Murphy's just kicks my ass every single time. So I guess there's nothing left to do but simply take it apart again. Once again, I don't have to get the lens out, but I'll take it apart. I'll get to the main board and just see if there's like power on the main board and stuff. So anyway, I'll take it apart. I'll spare you the details. Watch the previous video if you want to see this thing taken apart. So I'll get right in. Oh, and by the way, if you want to work on this safely and not get zapped like I did, then yeah, I've actually found the flash capacitor. It's in here. You can actually probe these two here, and you don't even have to get through the, it looks like that's just copper on the surface. It looks like it doesn't have any like resist or anything like that. So there you go. If you want to discharge it, of course, I'll have to use a different meter than my BM786. So what we need is a meter with a phantom voltage resistor auto voltage mode on it. So let's get in there and we'll probe that and that, and that will put a resistor across there, and it's already dropped it down to 8 volts. So that is completely safe, and we'll probably get some recovery on that voltage there. Yeah, it's going up. It's recovering a bit, but of course that's completely safe to touch now. I don't have to worry about it. Yeah, so that's what zapped me before. That will slowly drain away. Of course, you could use a resistor, whatever. Oh, sorry, I forgot to show you. But the ribbon cable in there for the LCD, that seemed to be in fine. So, yeah. All right, I'm back into the PCB here. This is off to the sensor. We know the sensor works fine. This goes off to the switch on the top. But that one looks for all the world like it's fine. But once again, we'll just reseat them. Could argue that one wasn't fully in, so that looks pretty good. I don't know. Let's whack a battery in and see if she powers up again. And power it up without the LCD. No. Nope. I wonder if there's like a power on sequence to like reset it or something like that. I don't know. That wouldn't surprise me if there is. Yeah. All right. So that's nothing. All right, let's call up the NI virtual bench and measure some voltages, shall we? Let's do that again. Nope. If I hold it down, does anything happen? No. Anyway, do a couple of little probies on here. Nope. 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 And assume that's ground, and no, we're getting, there's nothing on this board. Zippity doodah. Once again, I don't want to have to get into that board again, that top board, because I've got to take everything off when I do that. It's like it's just dead. Like, it doesn't recognize the soft power button at all. But unfortunately, we can't get this thing out and then probe that top board. Stick the screen back in, just in case. I don't know, that's the first thing it detects or whatever. Okay, that's in there again. It doesn't look like it's in all the way, but that's in as far as I can push it. Well, can I flip it over? Yeah, I can flip it over. There you go. No worries. That'll keep it insulated. No, it's just died. Like, seriously, I didn't do anything to it after that video. All I did was just leave it for a bit, like, well, overnight. And, like, it worked when you saw it. It worked when I reassembled the thing, and I just left it overnight. And it's come back and it's just failed. I can assure you that battery's good. There you go, 4.14 volts. I know it's negative, so all the electrons have fallen out, but I don't know. What a pain in the ass. Bloody Murphy. Anyway, as for the scrolling screen thing, it's got to be the connection cable? Well, there's two faults. One is that it scrolls, and B is that it also is upside down. So, and that it did not flip when I flipped the camera. And normally that happens when you flip, the screen's normally like this, and you flip the screen over like that. Now, there's, so let's talk about that one first. There's only two ways to actually detect that, whether the screen is flipped up or not. One is to have an accelerometer do that, and it can't be in the camera. It's got to be in the screen, right? Because otherwise you wouldn't be able to detect that the screen's flipped up while the camera's stayed in exactly the same position. Or it could have some sort of sensor contact micro switchy thing that actually detects that the screen's gone up. Once it goes up to a certain angle, then it flips. But I don't see how that would be possible. So it's most likely some sort of accelerometer, but it's got to be in the screen. So that means it's got to go via this ribbon cable here. Now, of course, this is all the connections for the LCD. We know all the data lines are working, all the clock lines, everything's fine, except it's scrolling. So there's got to be some sort of vertical sync signal here. Horizontal, if they've got a vertical sync signal, they probably have like a horizontal sync, or that could be just the clock. I don't know the interface for this one. Yeah, it's got to have like a vertical sync pin. But then that doesn't explain why the accelerometer's dead. So it's almost as if, like, okay, let's assume that there's a vertical sync pin on here, right? Then we know that, okay, that could be flapping around in the breeze. Could be floating, and that's causing the problem that we're seeing. That could be due to gunk, so, like a bad contact. Could be due to a broken trace as well. But then we've got the accelerometer problem. So let's assume it's a bad contact. We can maybe clean it, get some isopropyl in there, expect it, and stuff like that. At least the ribbon cable anyway, get some ice, flood the connector with isopropyl, and I don't know, give it a good shake around. But then, like, the odds of the vertical sync failing, and also maybe some connection for the accelerometer or something, both being like bad contact, unless they're both up one end of the cable or something. We can't solve that problem until we solve the problem of this stupid thing turning on. So we're going to have to go to the service manual. Now, thank you to somebody who sent me the service manual. Unfortunately, that was like a Mark 1 version of it, but I was actually able to get the service manual for the Mark 4 model, but I had to pay for this. I paid a whopping $5 Yankee bucks for this. So yeah, click like down below. I've got to get my money back for this video in ad revenue. And I do believe this is the updated one. So anyway, look, self-diagnosis function. Like I have not looked at this, but this is pretty great. Okay, identifying parts, and I could have just got the service manual and figured out how to take this thing apart properly. I was lucky that I didn't actually damage anything, taking it apart and putting it back together. So board assemblies, it's got everything. I mean, Sony service manuals are so comprehensive. It's absolutely fantastic. Wish they'd just put them on their website. Like, why not? Version. But here's all the flat flex, they tell you how to do the connectors and everything. And then they've got like just great diagrams of this thing. Thickness of the shim, I don't know what like software they're using there and stuff like that. They've got quite a few of those, but anyway, they do explain how to do all this. Even if those parts aren't in English, doesn't matter. But here's all the different assemblies. Fantastic. Like, it'd be awesome if these things were available for free on the Sony website. I mean, people would be buying Sony gear like crazy. Well, Joe Average doesn't care, but they'd get a good rep, Check out all these exploded views. Like, that's the heatsink assembly and stuff. It's just, it's fantastic. Look, it shows you how the flat flexes lay out and stuff, remove the screws, disengage the screws, how to get everything apart. Oh, wow. Like, there's probably, it has, where to put all the tape and stuff like that. There's the ring and there's the lens assembly. Anyway, what I'm really interested in is the schematic to basically show me what that top control board does, and how that's like soft power function works, because we've got to solve that. Obviously, like, there's some sort of intermittent thing there or something like that. So anyway, oh man, I could spend hours just looking. No schematic! Wah, 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 wah. I've been diddled out of my $5. There is another version of this though, so I might download that one as well. So I'll get back to you. Sure enough, yep, there's another 80-page service manual here. Let's have a squiz. Okay, so this has got all the parts list. This has the block diagrams, the frame schematics, and the schematics. So there you go. It's 2 different documents. So 180 pages. Look at all this. Look at the BOM. Wow, that's incredible. Oh, man, imagine if you could just download this from the Sony website. But look at these block diagrams. This is absolutely fantastic. Wow. Hats off to Sony for actually producing these. These are brilliant. Okay, flexible board, battery terminal. Okay, here we go. Right, so this is interesting. Check it out. We have the battery terminal on there, but we also have, there's the lithium backup battery. That's what's obviously reset it. When we disconnected all this, and took the whole thing apart, it obviously lost all its factory settings, and that had to do with, well, the lithium battery is on the flexible board. I simply didn't see that. I don't know, did you see that in the previous video? I didn't notice it. But anyway, yeah, that lithium battery. So resetting that, like, reset the thing. It made it work. So maybe if we, like, disconnect that again, we can at least get it, maybe reset it again and back up and running. But then why it failed, again, just sitting there overnight, I have no idea. But at least we can potentially get that back up and running. So I'd be surprised if that didn't work. That's that bottom side, like 2-pin, it was, yeah, 2-pin power. That's what we measured. It must have had a third one on there. So if we can just disconnect that, which is the one on the underside of this connector. So I think even if we have to lift the board out, it's not a problem. So yeah, hopefully we can get back in there, and that's going to be the first thing I'm doing. I just want to get this booted up again. I'm going to disconnect that again and see if that actually kicks it back into action. I could take it out without taking the board out, but then plugging it back in without taking the board out, nah. So yeah, let me take the board out. Gotta take that bracket off again. I want to keep all the ribbons intact. Got it. We can power it up like that actually, but I don't know what this little tiny ribbon over here does. I don't think that matters. It's not making an electrical connection, no. So this is just a push on. So I still don't know where the battery is. It's in there somewhere, is it? Oh, bugger. I just pulled out that as well. I'm going to have to push that back in. Actually, I can't remember. Where did that one come from? Is there a connector deep down on the back side down in there? Oh, God, I'm going to have to go watch my previous teardown video. Yeah, sure enough, watch my own video, and the back of that board does have a friction connector on it. It's not a bar one. So, yeah, like I can't see it. Maybe if I don't know, I need a light directly down. I'm probably going to design like a custom ring light for this, I think, for my Tagano microscope that sort of just attaches to the bottom here and just comes out wide so I can like light up directly. Like I've got lights from I've done videos on this, got lights from either side, light from the front here, but technically nothing coming down. Even if I turn on the Tagano internal light like that, it's coming down at an angle. It doesn't go directly down. So yeah, having that, the ability to do that would be nice. But anyway, I'll fiddle around with this, and I should be able to do this using feeler vision, just to feel that it's gone back in, because if it goes in and you know, have a bit of trouble sort of tugging it back out, then you know it's in. So give that a whirl. No, didn't have any luck. I think I'm gonna have to take out the SD card. Oh damn. Okay, those ribbons are out. Flippity doo-dah. SD module. Fantastic. So I can get back in there now and reconnect that ribbon. Don't know how I pulled it out. A bit of tape flapping around in the breeze there. I can see it now. Yeah, you can't, but I can. Yeah, ideally you'd take the battery compartment out as well, but nah, screw that. Have a go, you mug. Come on. I think I got it. That went back in pretty easy. I think it's in there. It feels like it's in there. Once again, it's just feeler vision. I can't actually see it. I'll just reassemble. I both love and hate flat flex. Is that possible? Oh, the bloody ribbon cable's come out again. Just wondering, could that be the cause of the problem? Did that cable like slip out or something? And I don't know. I can definitely feel that is in. Definitely felt the friction. Got to use your field of vision. Your Mark 1 field of vision system. Now, I'll be extra careful to put this back in this time without touching that bloody ribbon. Maybe that's what some of the tape is for. Maybe I can just temporarily tape that back. Yeah, there you go. Just tape that sucker back out of the way. Power cable back in. All right, all the ribbon cables back. And now let's do the infamous ribbon cable. Oh, I didn't even look at the schematic for that sync line. I was too excited. I was too excited to even clean that with isopropyl. I don't know. I just want to really get this going. I'll leave this taped up here. I'll leave this taped out of the way like this because I'm sure I'm going to have to diddle with this board again. In fact, it looks pretty askew. So, but I just want to see if I'm able to. I need a bit of insulator under there. Let's give that a burl. And where's our power button? Nope. Wah, 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 wah. Of course it doesn't work. Zippity doo-dah. Yeah, I don't know if I got the patience today to investigate this any further. Oh, there's an accelerometer there. There you go. Got him. That's not the one in the screen, but look, up here, it's, no, H and right, so it's got backlight. So the LCD, and you know, it doesn't show sync up there. We actually need the pin out of the LCD, but like that's inconsequential, the scrolling problem. It's the boot problem. That is the problem. Pitch in your sensor. There you go. It's an SE7701. Focus drive motor, LED drive, wireless LAN, CPU, camera, DSP, AV, single processor. Are they pin numbers? AD1, W31, I guess they are. Of course, that'd be one of those BGA jobbies. So image sensor, right? So the image sensor, that's all serial. So we want LCD. Here we go. Yep, H drive, V drive. So it's got horizontal and vertical. Yeah, so there you go. And of course the flexible to the, no, that's to the viewfinder, electronic viewfinder unit. Pin 6 or 26 over here. So anyway, yes, there is a vertical sync. VD, vertical drive, I guess they call it. And yeah, so obviously the clock works, the horizontal works, all the data works, all your three data, you know, all of your three groups of data up here, red, green, and blue, they all work fine. Your power works fine because the screen works. It's just lost vertical sync. So that would be that line there. That it must be open, and that's what happens when the line opens. So yeah, just dodgy contact or something like that. But there's no accelerometer in this LCD unit, is there? So how are they detecting that the screen's flipped up? Is it some register? Maybe like the LCD actually has the... We'd have to look for the LCD board schematic, I guess. But yeah, like as I said, like it's not a hinge thing, and the camera can stay completely still, not move the camera, and you flip the screen up, and it detects that the screen flips. So obviously there's an accelerometer or some sort of switch in the LCD that detects once it gets to a certain point, it flips up. Anyway, that's neither here nor there. I think we can fix that. Like, you know, it could be a broken ribbon, dodgy contact, whatever. Because it was obviously working fine before I took it apart. Well, no, it wasn't. Well, last I used it, it was working fine. Then I took it apart and reassembled it, and the vertical screen came back. But why? Why the battery thing? Oh, they've got a thermistor in there. That's the overheat. That is the bane of every digital SLR. Right, so underneath this, we have our... These are our actual schematics. So the other was like block level stuff, but here's the real deal. That's a CMOS imager. There you go. That's the imager itself. It's a Sony sensor, I believe. Yeah, Sony make sensors for most of the cameras out there, don't they? You know, companies will advertise it as, you know, you get one of those little webcam-y things. They'll advertise it as having like a Sony sensor because they're the best. Anyway, that's their big 1-inch jobby. Electronic viewfinder serial interface. No, this is great. I mean, just imagine having, you know, if you really were keen to spend the hours to fix your Sony products. These things are just fantastic. LCD module. Yeah, vertical, yes, pin 26 as we saw before. Yep, but there doesn't seem to be, there's a test pin. Wonder what happens when you do the test pin, when you short the test pin. Normally they leave it open, but backlight, X, what's XS clock and X reset? Is that sensor? Because the clocks were somewhere else, I thought. Yeah, D clock, so what's XS clock and X reset? I don't know. It's renamed AVS clock and XP EFV reset. Oh, geez, okay. There's an ambient sensor output as well. Light gate. So it's got a ambient light sensor. There's your pitch yaw sensor. Sounds serious, doesn't it, when they call it pitch yaw? You're flying. There you go for you antenna aficionados there. Manual ring rotation sensor. There you go. So there's the optocouplers for the rotation for the ring. Pop-up detect. No, that's the viewfinder pop-up, I would imagine. Right? Strobe. No, that's for your flash. Right, so your strobe is your flash. So yeah, so it detects when the flash pops up, and it, yes, it only charges the capacitor when you, I think, when you pop the flash up. Or it might keep it pre-charged, so then when you pop the flash up, whoop, it's ready to go. But anyway, the sensor needs to know whether or not the flash is popped up, whether or not to automatically activate it in auto flash mode, because it's not dumb enough to flash it while it's pressed down and it's inside the body. It's got another 3-axial acceleration sensor. So yeah, I could spend hours going through this in detail. A roll sensor. God, a roll sensor amp? It's got gyro roll. It's how many bloody sensors, accelerometer type sensors does it have? There's the eyepiece sensor. So I think I mentioned that in the last video when you put your eye up to it. LCD rotation detect. So that's on the flexible board. Okay. Okay, so it's not built into the LCD. It's on the SE1010 flexible board. Yeah, so we could search for that somewhere else, but the LCD rotation detect, obviously, yeah, it didn't work. So there you go. It looks like it does, like with another chip. It's not a light sensor, because when the screen's always in there, because you can pop it up 90 degrees and it doesn't flip it. So it's only when you pop it up like 180 that it actually does that. But anyway, I'm not worried about that. For those wondering how they do their flash charging, there you go. There's your big ass cap. 330 volts. That's the thing that zapped me. 46 mic. There's your driving transistor. So it's all happening now. NFC interface. Blah, 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 blah. DC to DC converter. Over voltage protector. Now we're getting into the processor, yeah, CPU. I like how they've compartmentalized blockletized? The word's obviously not going to pop out of my head. The individual functions here. And that's how you draw schematic symbols, by the way. Especially when you got big complex ones like this. Separate them into functional blocks like this. It makes your life a lot easier. You wouldn't have like sometimes it's better to have like the actual pinout of the chip. Other times, no. You want, especially for complex chips, you have functional things like this. It gets to a certain point in chip size where, yeah, it's better to do all that. Makes more sense. Yep, and that just keeps going and going and going and going. E-fuse. Wow, that chip's got everything. Is that a fully custom ASIC? Like, wow. CPU, GPIO, like, it just keeps bare. It's got bare, etc. Power, CPU, camera, DSP, AV signal processor, lens control mic. Yeah, it's got everything in this chip. Oh man, these schematics go on forever. There is a fuse in there. There's a 1 amp jobby in there. And oh yeah, there's another one as well. 0.63 amps. 24 volts. You could get a fuse blown. Oh, another one over here. 2.5 amps, 32. Wow, there's 3 fuses inside this thing. There you go. Got a couple of little regulators there. I2C, DC to DC converter. It's all happening. Still haven't found like the battery. Oh, battery unreg. Is that it? Voltage detect. Battery unregulated. Battery sense switch. See, it could be something like that. Like, it's not detecting that the battery's in there, so therefore it's just not, even though power's applied, it's not powering. Like, it could be anything that's stopping this thing powering on. X power on accessories. Looks like they had a component in there and they just jumped it over. X power on P row, whatever that is. Like, oh, we're back to the EFV again, are we? We didn't, so we've missed the battery. 0.4 volt regulator. Wow, what do they need a 0.4 volt regulator for? Holy mackerel. 0.4 volts, plus 1.2, plus 1.8. If you think you got power rail problems, spare a thought for the Sony designers. 0.4 volts, 1.2 volts, 1.8 volts, 2.5 volts, 1.1 volts, and there's more. I've seen other regulators, 1.8 and 3.3, and that's just this one page. Wow, and there's more, is there? Is that another 1.1? What is that? That was a different 1.1. That's another switched 1.1. It's nuts. No, well, that's it. I didn't find the battery. Oh, the battery. It's in there somewhere. I really, but check this out. Look, they got pinouts. They got pinouts. Ah, beautiful. Anyway, there's that battery board with the flex, and it's got tiny little coin cell lithium on there. That'd be would it be soldered in? Maybe. Oh yeah, there you go. It's got those extra. That's where the battery goes on that pin 1 there. Tiny little pin 1 goes over to the coin cell there, and then it shares the ground. Wow. But anyway, yeah, like, because we measured that. Like, we were getting power on there. The coin cell shouldn't matter. If the coin cell's not there, it should still boot. It just wiped the CMOS memory, that's all, and just wiped the settings, which it did. The whole thing just factory reset. But no, we actually measured that. We were getting voltage on there. It wasn't a problem. So we're getting voltage onto that. These are all gorgeous. Look, they've even got the pin numbers overlaid on there and the component designators. Oh, it's a thing of beauty. It's a joy forever. Beautiful. Look at this. Look at this. Got the board overlays. It's fantastic. Anyway, that's pornographic, really. Demonetized. Anyway, there's our main processor, isn't it? Yeah, there's our main processor. Have they got individual pins? Yep. Look, individual balls. Look at that. Look at that. This thing has balls. Wow. The engineers who put together this service manual, it's just brilliant. It's absolutely brilliant. Look, we can get all those, so we measured a few of those caps and stuff, and like nothing was getting over there. I'm going to call it quits. This video's long enough, I'm sure. So this will be like, it's just a part 2 follow-up look at that, and maybe, yeah, I'll spend some time, go through the manuals in more detail and find where and how the power system and boot system works, because obviously there's something wrong there. But why I didn't touch it. It was just sitting there overnight. It was working when I finished that video, and then I come back the next day and it didn't work anymore. It would not boot. Yet it booted every time I was doing that video, and there were more boots that you didn't see. They're in the edit, because the edit was, I edited out a lot of stuff from that video, even though it was 57 minutes long. It was like 2 hours of footage or something. It just booted every time, and then all of a sudden came the next day and it didn't boot. If you've got any idea why it would do that, I'll put a link to the service manual down below so you can have a squiz for yourself if you're curious, and just just drool over all of the there you go, 2015 official release. Wow, is it that old, the camera? Yeah, probably. Yeah, it's up to Mark 7 now. This is the Mark 4 jobby. Anyway, I'll make these available, and you can see for yourself. Wow. All right. Anyway, hope you enjoyed that. If you did, give it a thumbs up. Catch you next time.